Good afternoon, and welcome to the 52nd Annual and First Ever Hybrid Senior Design Conference. This is Computer Science and Engineering Session Number 1. My name is Joseph Pham, and I will be serving as a session chair along with my partner, Jaylene, to moderate this session. There will be 4 teams presenting in this session today. Each team will present their senior design project live from this room, followed by a 5-minute question and answer period with our alumni industry judges. This session will also be live streamed on the Senior Design Conference website. We will now start with our first presentation of the session. Out of respect for our presenters and live stream audience, and due to the sensitivity of our audio system in the presentation room, please refrain from side conversations during the presentation. I would now like to welcome the senior design project titled AI Music-Based Emotional Regulation, Amber.
Awesome. Hello, everyone. Thank you for coming to our senior design project. As Joseph just said, we are AMBER, which stands for AI Music-Based Emotion Regulation. I'm David Krakauer.
I'm Uma Ball. I'm Betty Howe.
I'm Zabi Underhope.
And of course, our advisor is Dr. Maya Ackerman. So I want you to all take a moment and just reflect just a little bit on your experience with the pandemic. I know for me, when I think of my experience with the pandemic, it's filled with a lot of struggles with mental health and getting stuck in isolation and stuck in that thought loop of just being stuck alone in isolation. And so for me, coming into my senior year, a big focus that I wanted to do in my senior design project, and I think something that resonates with our group as a whole, is how can we address some of those mental health issues, and how can we create a product that addresses some of those solutions and builds something that works towards that and works towards helping mental health as a whole.
So as it turns out, that sentiment was shared across adults in the US. So in January of 2021, at the peak of the pandemic, a study found that 4 in 10 adults, US adults, were reporting symptoms of anxiety disorder or depressive disorder. And this was up from 1 in 10 just 2 years prior, right before COVID hit, when about 11% of adults reported these symptoms. And in addition, a lot of adults expressed increased symptoms of struggles with mental health, and such as increased substance abuse and alcohol consumption, worsening chronic conditions, and all due to the stress of the COVID pandemic. And so as a group, we wanted to think about how technology, and specifically our computer science and engineering skills, could be used to help the community and specifically our users. And we turned to music as an easily accessible tool that a lot of people use for emotional uses. And so different moods are fit for, different music is fit for different moods, different feelings and emotions. And this led to our vision as a project. So our project is an interactive web page which allows users to input emotions through information on how they're feeling, and then receive song recommendations with the goal of helping their well-being. And before we wanted to build this project, we wanted to do a lot of research to make sure we understood the field. And so one thing we looked into was the emerging field of music therapy. So music therapy has a lot of applications. It can be for general anxiety and depression. Even for couples therapy, there are also applications for motor control disabilities. And we found a lot of existing applications and papers already. So one of them was DJ Running, which is a app that will give you song recommendations to motivate you as you run. And then another one was a study done on how music therapy can be used for addressing depression in young adults, and it showed how effective music therapy could be for that. And then one that really stuck out to us was the use of dialectical behavior therapy together with music therapy. So DBT is a type of cognitive behavior therapy, and it's used to find and identify negative thoughts, negative thinking patterns, and try to push the patients towards positive thinking. And another thing that we looked into was audio analysis tools. And so we wanted a tool or an audio analyzer that could give us information on songs. And the one that we ended up using was the Spotify API, because it gave us really valuable information on different songs. And then the last thing that we looked into was how to represent moods and emotions. Because coming as computer science engineers with not a lot of psychology background, we wanted to make sure that we were working in this field in a way that was going to accurately help our users. So now we're going to do a quick demo of our application.
So this is how you're presented with the front page of our app, and then you go and log into Spotify. This is just all through Spotify right now. And then it takes you back to our app, and you can see very simple interface, asks you how you're feeling. You can adjust the slider, so we're going to do some high energy here, high positivity. Very simple, those two metrics. And then we have two options to either show opposite songs, or in this case, we're going to show similar to that motion that we put in. So now it's calling our backend, and then it'll start playing that music from Spotify because it's hooked up to your Spotify account. So it'll just start playing that music right then. It gives you a bunch of other recommendations in case you don't like that specific song. I'm going to turn it down a little bit here. So you can see, you just scroll through all the different songs. You could choose and select a different song, and it'll start playing that one. So you really have a lot of options here. And then just for example, let's say show opposite songs. So now you want to maybe feel opposite to that emotion that you put in, or you just want to see what kind of music is kind of opposite to that. So now we're on the other side of the spectrum. So you can hear this song's a little bit more mellow, lower energy. Come back to Earth, and then there's all the other recommendations. And then just for example's sake, we can just move those sliders down, move the positivity down as well. And then we're going to do show similar here, and that'll select, show similar songs to what that previous search was as well. And you can see it's just kind of multiple different ways to have different types of results to just really match whatever you want to feel at that time, or whatever you want to listen to.
And the recommendations will be curated based on your Spotify previous searches and your profile. Yeah. So going into how we actually built this, so the 2D input mechanism came from the Russell circumplex model packet, which we found as an established form of representation for emotions. And so the Russell model is from 1988, and then it captures emotions based on this 2D polar scale, where the vertical axis shows the energy level from activation, high activation to low activation, and then the horizontal axis shows valence, so anywhere from positive to negative. And based on this polar space, you can map emotions on any place. So for example, excitement is a high activation and high valence emotion.
So then here's a brief overview of just what was going into powering that application you just saw. So the front end is in React, that's powering those views and the text that you saw on the page itself. And everything behind that is just part of the back end, what's going in, feeding the data to it. So the Spotify API, we're just getting that information directly from Spotify, like the song, song name, song artist, and actually playing the songs coming from Spotify. Then we have a whole suite of AWS, Amazon's AWS services for the back end, like API calls, and also the machine learning is using SageMaker and S3 to train the model. And that Genius API is another third-party library that just provides us some additional song data for like lyrics to help enhance the training of the model. And Umar will talk more about that backend now.
So we have this great Russell model that we discovered, and we were trying to figure out how do you then, when given a song, figure out what emotion the song has, and how do we know whether that emotion matches what the user is looking for? So we had two main approaches to doing this, and the first approach was to just take a look at these 8 labeled emotions that were defined by Russell, and to just take those as like the 8 main emotions and see whether we can categorize songs into those categories. So to do this, we used a random forest classifier, and the way that it worked was we would take a song and then put it through the Spotify API to then get audio features such as danceability, energy, tempo, and valence. And then we would put those audio features into the model, and then it would return a label. Like, for example, there's arousal, there's also excitement, misery, like the ones we saw in the circumplex model. And in order to train a model, we needed a large data set. And what we were seeking was a data set with these Spotify features, along with these labels that are specific to the Russell model. And as you can imagine, it was not very easy to find a data set like that, so we actually went ahead and created our own data set. We went through Spotify playlists such as, you can see here on the right, Happy Hits. So Spotify has a lot of different mood playlists like this where you can see there's almost 6 million likes on it. So 6 million people will listen to this playlist and say, yes, it has happy songs in it. So we went through every single song in the playlist, extracted the features, and then assigned the label based on the playlist and made our data set that way. Our data set had about 5,000 songs, and it was balanced with about 500 to 600 songs per emotion. And after training our model with this data set, we achieved 95% accuracy using k-fold cross-validation with 7 folds. We also tuned on hyperparameters such as the size of the depth of the forest as well as the number of estimators. And we deployed this model using Amazon SageMaker. It was then, we put the training data in S3. We hosted the endpoint of the model using EC2, made it accessible to our web application with API Gateway, and then Lambda was used to call the model. So while this was a great first attempt, there were some drawbacks to it. The first being that we were just going off of 8 emotions. And so that's kind of like a limited amount when you think about the range that people can feel. And we kind of noticed this during our early testing when we would put in our emotions and then kind of get songs that didn't really match that much. So we actually spoke to Dr. Huria Jazayeri, who's a professor here at Santa Clara University who specializes in emotions. And she talked to us about how having discrete emotions like that can be kind of difficult because what is happy to me may be something that's like more energized versus to someone else it might be something that's like a little more calm. So having labels like that is a little bit ambiguous. So that led us to our second approach, which was to actually just ignore all of these labels and then go back to the fundamentals of what the model was, which was the axes of energy and valence. And so if you have a user that's feeling like medium energy and medium valence, then you can say, oh, they're probably like feeling an emotion similar to excitement. Versus if someone's feeling like kind of low energy, kind of low valence, like we might not have a particular label, like what emotion that is, but with using this model, that doesn't really matter because we're just looking at, what the emotion is with this. So to implement this, we use the Spotify audio features of valence and energy. And this is what we currently have deployed, and there's a lot of advantages to this approach. The first being that it is almost 10 times less expensive than using SageMaker, and it's also a lot faster because you do not have to run the songs through SageMaker every single time. It's shown very promising results, as you'll see through our user testing later. And I think the most important part of using this is that it aligns really well with our dialectical behavior therapy goals. So if we have a user that's feeling sad and they want to feel a bit happier, we can exactly pinpoint like where we want to bring the user in terms of energy and valence, and then we can use Amber to bring them there more directly through this continuous space.
Absolutely, and so that kind of leads us into some of the ethical questions surrounding our project. We kind of started with this first question of how do we build a system and build a product that's effective, that actually recommends music that either aligns with someone's mood or moves them towards a different mood. And so now that we've kind of answered that question of building a product that's effective, how do we then move on to building a product that is doing that in a responsible way, that's doing that in a way that does it with the user's consent and we don't have to worry about different damaging things to the different user. So this is kind of the core question that I think us as a group really had to discuss and think about. And I think more than that, I think it's a key question that a lot of AI and machine learning products as a whole in the industry have to answer, right? Do we have a moral obligation or an ethical obligation to ensure that our system is working towards the well-being of our users? I think the example that we discussed as a group a lot was if we have a user who's feeling sad, and they ask for sad recommendations, we don't necessarily want to recommend music that's going to make them feel worse and continue them down that spiral. And so I think the answer that we kind of came to and the conclusion that we came to for our group in building out this project is yes, in a way, we do want to give music recommendations that are going to make people feel better. But at the same time, we want to do it in a way that gives them full agency and gives them full control over the music recommendations that they receive. So if you remember from our demo, we gave them the two options of receiving similar songs or receiving opposite songs, as well as full control over the sliders so that they have full agency in terms of this big ethical question.
So that led us to our user testing. We had our prototype, and we collected 20 tests from users across campus and some outside as well. And all the users followed a three-step process. So first, there was a pre-test survey that collected data on how they were feeling beforehand. Then they were advised to use Amber for at least 10 minutes. And then there was a post-test survey, which asked how they were feeling afterwards and also collected some data on how suggestions and feedback on the app. And so, again, we were able to get 20 tests, which is just a preliminary set, but gave us a lot of good feedback, and the average usage time was for 15 minutes.
So some of the results we saw from those 20 tests that we did, this is for people who chose to show different than the emotion that they had inputted. So you can see over 90% of people actually found that it was effective to some degree at actually affecting their music state one way or another. And so that's really, really amazing. And even over 50% said it was moderately or very effective, which is awesome to see. So obviously still a little bit of work to do with that green area that said no effect. So we can definitely make it better, but very cool to see that there was that many people that actually found it effective and altering their emotional state one way or another. And then on the other side of that, for the people who chose show similar, so that's just playing the same type of music than as the emotion that they had inputted. Overwhelming majority said yes, it did correctly identify with that emotional state that they had put in. So again, there's still that little chunk that said maybe. Nobody said no, surprisingly, but at least it wasn't far off from what they were feeling if it wasn't exactly that. So very promising results there.
Another thing that we saw that was really interesting was that the overall emotional state of our users actually improved. And so again, we asked them how they were feeling before and after, so the pre-test and post-test surveys. And we saw that the percentage of people who responded slightly positive and very positive both increased. So very positive went from 12 to 15, and slightly positive went from 44 to 60. And as well as the people who responded negatively, either slightly or very negative, those percentages both decreased. And in the same vein, the energy levels of our users overall also increased. So people who responded high or medium-high, those percentages both increased, with medium-high people responding in the medium-high range going all the way from 20 to 35. And then people who responded in the low responses, so either medium-low energy or low energy, those both decreased significantly. And so we saw that with our users, even though they only used it for say maybe 10 to 30 minutes, the overall both emotional state and energy levels of our users both increased. And so that's again very promising and aligns with our overall goal of our project, which is to improve the well-being of our users.
And so two of our other main goals for our project was to both not only provide really good music recommendations, so music that you actually want to listen to, but also music that matches your emotion. So we've just included some feedback in both of those areas here. You can see people thought the music was perfect, recommendations were good. They liked discovering new music with our app. And then emotion matching is the big part of it that we wanted to add as well. So not only is it music that you like, but it matched the mood, it made them feel happier. It detected songs based on the mood that they were in. So all of that is very promising to see, and we loved getting some of that qualitative feedback to make sure that we were still aligning with those goals that we had as well.
Through our user testing, we also got a lot of really valuable suggestions, and we kind of saw a couple suggestions that fell into one category, which was maybe the background of the music or like the tempo was really good with matching the mood, but then the lyrics didn't match up that well, or maybe they got a ton of recommendations that were all pulled from like different genres, and so the listening experience was a bit disjoint. So to address this, because we see a lot of potential with customization for Amber, we decided to go ahead and use the Genius API to then go through all of the suggestions we're making, access the lyrics, then extract features from them using term frequency, inverse document frequency, and cluster these features into 3 categories. So then the user is presented with listen to songs like these or these, and then like a 3rd category, and then they can better curate their listening experience based off of that. So this is just one of the examples of how we're really excited to continue just providing better recommendations to our users that align with the mood that they're looking for.
And so as we kind of look forward onto the next steps of our product, we worked on this for a full academic year, but as with software engineering, there's always a bunch of stuff that we want to add or things that we would do. And so some of the things that came to our mind first in terms of things and next steps that we would take, first, doing some kind of user mood tracking. So as we give recommendations, keeping track of the user's mood over time. And then from that, the big idea we had was using the ability to like or dislike recommendations. So if you get one recommendation that's good, you can upvote it, and then we can give more recommendations closer to that. Or if they dislike it, we can make it less like that song as well. Just so as you go, the recommendations improve. And then next, exporting playlists. We worked with the Spotify API, and so just giving additional tools to users and additional features. If you're going for a jog, for example, you can hit export the top 50 songs, and then it'll load onto your phone so that you can listen through the Spotify app there as you are on your jog. Another thing, kind of along with that, building out a mobile app so that users can switch from the Spotify mobile app to our mobile app, just to increase ease of access for users. And then lastly, psychology A/B testing. I think our product is really interesting because it kind of provides a platform that you could do different research. So on users, and so obviously with the consent of the users, you could do different studies and get information about, how does a user's mood change over time, how does it change in response to certain music, different things like that. And so when I take a step back and I think about our project as a whole, I think our key pitch is we're a product that's coming out of quarantine, coming out of the pandemic. And as we step forward and as we try to address the massive problem that is mental health, how do we address that in a way that's responsible, but also creates real value for our users and creates, even if it's just a simple step forward, make a product that improves their day. I was really surprised by the amount of my friends who had tested the product and came to me afterwards and said, hey, after this is all over, can I keep using the product? I really love going in and listening to music that is brighter or more positive. It really brings me up. And I think that really speaks to the value of our project and the value of everything we've been working on as a whole.
So we'd like to say a big thank you to Dr. Maya Ackerman for supporting us, encouraging us, and giving us great advice throughout the project, and also to Dr. Huria Jazayuri for helping us with some of the psychology side, and then lastly to the School of Engineering for their support and the funding to help make Amber a reality. And with that, thank you for listening. Please check out our video on, we were featured on the SCU Engineering Facebook, Instagram, and LinkedIn. And with that, we will be taking questions now. Thank you.
So I have a quick question. Great presentation, and I loved the idea. What were the metrics that were used to identify the pre and post test results? So there was a slide that showed pre and post test, and 50% and 90% of people actually showed some improvement in their emotions. How did you, was that a feedback from the users, or was there another app or a software that was used, or how did you do that?
Yeah, so if we go back to that slide, that was all actually just survey questions that we asked. So 1, 2 forward. Yeah, so we asked them, it was a multiple choice question in the surveys. They were given the same options before and after. And so they just selected how they were feeling, both their emotional state and their energy.
And how much time did they use this app for till you got to this status? I mean, when did you start the survey?
Yeah, the average use time was 15 minutes. I think the whole range was
okay.
between 10 and 30 minutes.
Okay. And a second question, in the beginning of the presentation, there was a discussion, there was a topic for Russell model, and I wanted to get a little more clarity. I think from Russell model, you moved to a different model later on, which only had energy and valence, and there were no labels that you were using, right? So is this still a part of the, I mean, how is that different from what Russell model does?
Yeah, that's a great question. So basically the Russell model kind of has 2 parts to it, where there's the, like you were talking about, the axes of unpleasantness to pleasantness, and then activation to deactivation. We kind of used 2 terms, like unpleasantness could also be called valence, and then the activation axes could also be called energy. And so you can see in the diagram there's kind of like points around. So that was Russell's way of kind of just saying like, oh, at this point this would be this emotion. So there are two parts to it where there is like, if you do follow the model, then you can identify those specific emotions. But then at the same time, they are just like points that are represented by the activation and unpleasantness or pleasantness. Does that clear it up a
Sure,
little?
sure, yes, yes. And with the newer model, you're not restricted to these labels. And you can cover and go anywhere around the XY axis to cover more points.
Yeah, exactly. So you could like, say an emotion here or like here. You don't have to kind of just be limited to the labels on there.
Great, thank you.
Yeah, I have a question. Actually, a couple of questions. The first one is Spotify API. Do you have to pay for that?
So with our current usage, we are actually using that without any costs.
And I think we could actually also request a quota extension, which I'm pretty sure is still free, but we haven't looked into that. We looked into it, but not.
So it's an API integrated into yours?
It is also, in our demo, we showed you log in, and so we actually get the authentication token from the user's account. So basically, you're using the user's account. So if they're paying for Spotify, then you can get like, they can get the features that they're paying for anyways.
The questions I have is that you mentioned you have 5,000 songs. So how do you, is there a training model behind it? So how do you do that? To train your AI?
Yeah, so we had a data set of 5,000 songs, and so when you have the model, you can input that into the training, and then it'll learn based on those 4 features, like if a song has high energy and maybe like high valence, then we can say that that's an excited song. So as it sees like multiple songs over and over again like that are mapped to excited, then it'll learn like these are the features that make an excited song.
I see.
So you start with a fixed training kind of a directory or a training set with say 5,000 or 6,000 songs. And then repeatedly the user is going to say whoever is using the app, that 5,000 data set remains as it. I mean, the training will go over it. So you'll have more refined training data as in how much, depending on how much the user is using the app, right?
So the way that when you train on the songs, then that can be fixed, but that is one thing we are looking into is then training on like the user's experience, because so when you train on the songs, then you're training on like how music is overall, but then if you train on what the user likes, then you can make like really good recommendations for them specifically. So yeah, it's a good route to go for the future.
If the user is preferring some frequency difference versus your app, do you change the frequency to what the user asks for, or it's difficult?
What do you mean by frequency?
It could be slow frequency or high frequency. So music, it depends on the music, what kind of frequency it is going after.
Yeah, so because we use the user's account, we can get songs that match up with their taste. So what we do actually is we look at their top songs and then make recommendations based off of that. And then with the sliders, they can then control like how much energy they want. So if they want like a lower frequency song, they can put like lower energy.
Even if it doesn't match with the exact emotion they're feeling at that time, they can kind of trick the system and just put, oh, maybe I want it to think I'm feeling sad, so then it can show me like sad songs. They can also do that as well with the way we have it.
Questions?
You ever thought about coming out with a song that will, based on the mood of the judges, will increase your score overall?
Well, I hope
Ethical question.
that would be a good song to find. Maybe we can. I'm sure we could find one. Hopefully.
We do think there's a lot of applications for this though, both for recreational use and like for actual medical purposes. So it's very versatile that way.
It is really cool once you start to use it and you hear a song, it's like, wow, that was pretty cool, and you think like you never would have heard that before, because Spotify will like that when we had that one slide up that had both music that you like but also music that matches your emotions. It's kind of cool when you get the fusion of those. And it's really different than just normal like what is usually music recommendations. think we're about out of time.
Okay. We have now concluded the question and answer period. Thank you to the project team for your presentation. We will now take a break until 2:50 for the next session, where we will begin then. Thank you.
Thank you.